Hello, welcome to this video. Today we will discuss about one of the interesting subject, the fluid mechanics and hydraulic machines. Let's get started. Properties of fluids. In properties of fluids, various concepts are covered like Introduction. Basic properties of fluids. Basic problems. Viscosity. Units of viscosity. Types of viscosity. Related problems. Thermodynamic properties. Compressibility and bulk modulus. Surface tension and capillarity. Vapor pressure and cavitation. In this video we will discuss about first four topics. Introduction to fluid mechanics. Fluid mechanics is that branch of science which deals with behavior of the fluids, liquids or gases, at rest as well as in motion. Thus this branch of science deals with the static, kinematics and dynamic aspects of fluids. The study of fluids at rest is called fluid statics. The study of fluids in motion, where pressure forces are not considered, is called fluid kinematics, and if the pressure forces are also considered for the fluids in motion, that branch of science is called fluid dynamics. Basic properties of fluids. Density or mass density. Density or mass density of fluid is defined as the ratio of the mass of fluid to its volume. The mass per unit volume of fluid is called density. It is denoted by a symbol of ρ. The unit of mass density in SI unit kilogram per cubic meter. The density of liquids may be considered as constant, while that of gases with the variation of pressure and temperature. Mathematically we can say the mass density as ρ equals to mass of fluid by volume of fluid. The value of density of water is 1 gram by centimeter cube. Specific weight or weight density. Specific weight or weight density of fluid is the ratio between the weight of fluid to its volume. Thus the weight per unit volume of fluid is called weight density and it is denoted by symbol W. Let we write this expression mathematically. W which equals to weight of fluid by volume of fluid, here weight of fluid which denotes as mass of fluid into acceleration due to gravity. So we can replace the weight of fluid as a mass of fluid into g, by volume of fluid. We know the mass of fluid by volume of fluid, can write it as ρ. So the expression became W equals ρ into g. The value of specific weight or weight density, W, for water is 9.81 into 1000 by meter cube in SI units. Let we move to next topic. Specific volume. The specific volume of fluid is defined as the volume of fluid occupied by unit mass or volume per unit mass of fluid is called specific volume. Mathematically it expressed as specific volume equals volume of fluid by mass of fluid. We know the mass of fluid can be written as mass of fluid by volume of fluid. Specific volume represented by 1 by ρ. Thus specific volume is the reciprocal of mass density. It is expressed as meter cube by kg. It is commonly applied to gases. And next important property of fluid which is specific gravity. Specific gravity is defined as the ratio of the weight density of fluid to the weight density of standard fluid. For liquids, the standard fluid is taken water and for gases, the standard fluid is taken air. Specific gravity is also called relative density. It is dimensional-less quantity and denoted by symbol S. Mathematically we express specific gravity for liquids equals to weight density of liquid by weight density of water. And specific gravity of gases can be written as weight density of gas by weight density of air. Thus the weight density of a liquid equals to specific gravity S into density of water. It expressed as S into 1000 into 9.81 Newton by meter cube. And density of liquid equals to specific gravity into density of water, which expressed by S into 1000 kilograms by meter cube. If the specific gravity of fluid is known, then the density of fluid will be equals to specific gravity of fluid multiplied by density of water. For example, the specific gravity of mercury is 13.6, hence density of mercury equals 13.6 into 1000 is equal to 13,600 kg by meter cube. Let's move to the basic problem. Calculate the specific weight, density and specific gravity of 1 liter of liquid which weighs 7 Newton. Here the given data as volume, which equals to 1 liter. We can write this by 1 divide by 1000 meter cube. Weight equals 7 Newton. We know that specific volume equals weight by volume. Substitute the value into formula, we get 7000 Newton by meter cube. And next we need to find a density equals repressant W by G. Substitute in formula, we get 713.5 kilogram by meter cube. And similarly to find specific gravity, the formula for specific gravity is density of liquid by density of water. Density of liquid equals 713.5 and density of water equals 1000, hence we get 0.7135. The specific gravity, which is no unit. Let we discuss another one problem. Calculate the density, specific weight and weight of 1 liter of petrol of specific gravity equals 0.7. Here the given data is again volume equals 1 liter and specific gravity, which is 0.7. To find a density, we know the density is specific gravity into 1000 kilogram by meter cube. Substitute here 0.7 into 1000, we get density equals 700 kilogram by meter cube. To find a specific weight, we know specific weight, which represent density into acceleration due to gravity. Substitute here, we get 6867 Newton by meter cube. Similarly to find a weight, W. We know that specific weight equals weight by volume, then substitute the values here, we get 6.867 Newton. And next topic is viscosity. Viscosity is defined as the property of fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of fluid. The viscosity together with relative velocity causes a shear stress acting between the fluid layers. In next video we will discuss about units of viscosity, types of viscosity, related problems, thermodynamic properties, compressibility and bulk modulus, surface tension and capillarity, vapor pressure and cavitation. Thank you for watching.